guys. I'm going to talk about Ruby and Go. My name is Lional Barrow. I'm a developer at Braintree. You guys might have read that Braintree was acquired yesterday. If you want to talk about that, come and see me at lunch. One other thing is that I've had a little bit of a cold, so if I start coughing into the mic, I'm sorry. So let's talk about Go. Here's the plan. We're going to give a little overview of Go. We're going to talk about what I call the Go agenda and compare how it works versus Ruby. And then we'll just have some takeaway thoughts. So what is Go? Go is a new language. It's about 5 years old, although the V1 spec has only been frozen for about 24 months now. It's a general purpose language developed mostly at Google, although it's entirely open source. The Go core team includes some some luminaries like Rob Pike and Kent Thompson. And it was originally marketed as kind of like a systems programming language, similar to C or C++. I think that everyone's kind of stepped back and realized that that was a mistake. It really should be thought of as a general purpose language. But if you just go on Wikipedia and look at like the categories of programming languages that we have, it is compiled, garbage collected, statically typed, and object-oriented. So it sounds a little bit like Java. I think that you'll find it's actually quite different. Go is noted because it has a lot of first-class concurrency support. It has also a very strong toolchain emphasis, including automatic code formatting and stuff like that. We won't really be able to talk about that in this talk, but I will say that like when Go first came out, it was kind of derided by a lot of people because from a programming language research perspective, it's actually extraordinarily boring. All the big ideas in Go's semantics and syntax have been around for like at least 30 years. The new stuff that the language brings is that it mixes together all these things like CSP-style concurrency, interface-oriented type system, and it kind of blends them together in a really nice way. And I think that you'll see that if you try it out, the stuff, all the different parts fit together very well. In that sense, and in general, Go is a language designed by software engineers for software engineering. So there's a lot more thought has gone into the language about things like dependency management, which from a programming language research perspective is really boring, but actually makes a big impact on our lives. So Go is blowing up. This is the most important way to track how popular a programming language is. Like hashtag tweets. I'm sure there's no way this is at all biased. But so it's, basically I think if you logarithmically plot this, it's a straight line. So yeah, it's doing well. So here's the thing about Go, is that Go really has an agenda. The Go language is very small. It has a very small number of keywords, very small number of ways to do things. And the whole language, the design, the like syntax, the semantics, the sort of idiomatic style is all oriented around pushing you down a particular path for writing code. And I think you'll find that if you are like, okay, you know what, I'm just going to see how this works, you'll be fine. But it really is a top-down style. It's a bunch of guys sat in a room in Mountain View and figured out what they wanted Go source code to look like almost all the time. So this is very different from the way I think Ruby's idiomatic style has evolved. We have for loops in Ruby, right? But no one uses them. And that's sort of just like a bottom-up thing. I would say that like set aside your reservations and don't fight the agenda. Don't try to write any language like it is any other language. Try to get the thing to work the way it's supposed to work. Okay, but what is the Go agenda? It's so terrible. The Go agenda is that you'll write code that is oriented around small, generic packages, that you'll write object-oriented code, but you'll really focus on composing objects together rather than having inheritance hierarchies. And most controversially, I think Go is really big on upfront error handling and treating errors as if they're data, rather than having special control flow mechanisms like exceptions. We'll talk about each of these items in turn and kind of compare how Ruby handles these problems. So we have small generic packages. So what's a package? A package is similar to kind of a namespace or a module. It's not quite the same thing as a namespace because a package actually can have internal state and it can run computations when it's first initialized. So in that sense, it might be considered more similar to a Ruby module. But basically, like all Go source code lives in a package. A package is basically just a collection of source files that are grouped together by this package identifier. And you think about their packages all the time. They're kind of your building blocks. Go has pulled an interesting trick around forcing you to think about the package API because whether or not you can import a name, like a variable or a function or a type, from a package is controlled by the case of the name in the package. So I'll show you a concrete example in a second. But think about this. It's like when you read the code, you immediately know whether or not you're looking at a public method, or public function, or a public type, or something that's private in kind of implementation details. It's a stronger convention than just having underscores or putting private on your, in the private part of your class. This is actually a thing that is enforced by the compiler. So I think that means that like there's a little bit less burden when thinking about like what part of the code am I looking at. And just as an aside, the main package executes very similar to Java. So this is what Go code actually looks like. We're in the Braintree package. We have two top-level public things going on here. We have a charge function, which takes as its input a credit card type and an amount string, and returns a Boolean. I'll talk about the body in a second, but we can just imagine that like the Boolean signifies whether or not the charge was successful. And then we have like a credit card struct. When I say type credit card struct, that is very, very similar to just declaring a class in Ruby. The difference, though, is that all I've done here is declare what the attributes of the class are, what its internal variables are. We actually add on the functions, the methods that the things can do later on here when we have like func paren c credit card is saying like this function is on the credit card like type. So charge and credit card are public, and anyone who imports this package can see them. Anyone who imports the package can also use the string method on credit card, which is very similar to like 2s or something in Ruby. They can also see last for and type, but they can't see number. So I can immediately look at this as a person just scanning the source code, and I know like, okay, number is implementation detail. I'm not ever gonna have to worry about it if I'm just like using the package. And then let's say we have some internal methods that I've left unimplemented just for space constraints, like valid is the credit card valid, and then actually doing the charge. So in my charge method up top, you'll notice I'm actually calling internal methods to the package. I'm calling like private methods on credit card, but that's okay because we're in the same package as credit card. Does that make sense? Okay, I see some nodding. So what does this look like if you're importing the package? Well, here's a main. You'll notice that like it's the same type as source code. It looks very familiar. We import Braintree as well, and two other things, fumped and os. Fumped is string formatting. OS I think is self-explanatory. And our function, our main program, is just gonna like grab the card number and the amount out of the command line arguments of the function, and we're just gonna say we're gonna new up a credit card. That's a method that I did not include in the last slide. Just imagine that it initializes the number and the type and the last four correctly. And we're going to try and do a charge, and if it's successful, we print something. If it's not successful, we print something else. And we're doing like some string interpolation there where using the %s will tell Go to use the card.string method. And this is what our output would be. So there's a couple things to look at here. One is that we always say braintree.new, whatever. But once we've gotten the type out, we don't have to like redeclare it. Go is very big on like inferring types whenever it can, which makes the code, I think, a lot less verbose and a lot more readable than C++ or Java or something. But so, interesting though, this is like the only way that you import external code in Go. Compare this with like what require does in Ruby. Require executes a lot of code and potentially defines a lot of things. Require is like a big deal in Ruby. And that allows us to do things where it's like requiring our spec helper, which in turn requires like our spec or whatever, allows us to define new methods that are not namespaced. I don't have to say rspec.describe, right? And that's a very important point. Ruby has a lot more syntactic flexibility than most other languages. And I think that this is like a blessing and a curse. Compared with Ruby, dependency management in Go, in this sense, it always feels very obvious where imported code comes from. You're never going to be surprised. On the other hand, this limits what you can do a lot of the time. In the same vein, you can't have import cycles in Go. Like, you can't have package A import package B and package B import package A. That's a compilation error. I think that that's actually okay. I find that these are usually a smell in design anyways. Another critique I'd make is that packages can't always be generic. Eventually, you have to stop using library code and start actually writing some like business logic, right? And it's not really clear to me that packages are the best way to model this. But let's move on and look at some other stuff. Agenda point number 2, let's do composition instead of inheritance. Everyone here knows what I mean by composition and inheritance, right? It's like Composition is just when classes coordinate other classes rather than trying to like get new behavior from some language-defined mechanism. Go has an interface-oriented type system. An interface, in the sense that a struct that we saw in the previous slide was a bag of attributes, an interface is a bag of methods. And the way Go works for implementing polymorphism is you are said to fulfill the interface if you, as a struct, have all the methods that the interface requires. And a function can take an interface type as an argument, and then any struct that fulfills that interface can be passed in. And I think that this encourages packages to be really, really generic, just to find an interface that they need, and then just go for it. So this is like what interface looks like in code. Let's say we have a database package that has a JSONer type, like JSON-er. The is kind of like a idiom. That has like a toJSON method that returns a slice of bytes, which is slice is basically an array. And then in some other package or models, we have users and posts, because we're doing blogging or something. And both of these things implement toJSON, which means that in my store in DB function over there, I can actually pass in whatever, either users or posts, and it'll just kind of know that the compiler can tell, like, oh, you've implemented this interface has this method, you can definitely call this method safely inside that function. But I would say that, like, if you look at that example, it's actually really bad. This is a bad interface. It's super repetitive. Notice how the body of the toJSON function is exactly the same, essentially, in these two classes. It doesn't really bias any abstraction, and I'm only really including it because I think that you kind of get a sense of how the semantics of interfaces work here. One thing to point out is that password, because it's private to the model's thing, will not be serialized into JSON because the other package can't see it. Here's a really good example of an interface. This is a real interface in the standard library, in the IO package. Writer. All writer does is it takes an array of bytes, it returns an int, which is the number of bytes that it actually succeeded in writing before it encountered an error, and an error if there was any. So what can you do with the writer interface? Well, files are writers. File has a write method. This is like a little bit squinting. I've like kind of renamed some things, but basically in the standard library, there's a response type for HTTP, which is a writer. And there's, what if I want to have a buffer of bytes? Well, I can just implement that as a writer as well. And think about this. I can guarantee with type safety here that any function that takes as an argument as a writer can safely operate, as long as the semantics are correct for these interfaces, or for these structs, it can safely operate on files, on HTTP responses, and on buffers of bytes. And actually on like 50 other things in the standard library. The writer is like one of the most common interfaces. There's also reader, unsurprisingly. So it's easy to build really high-level code this way, really high-level generic stuff. And if you want to like get your like custom type accepted wherever these guys are, just implement the interface yourself. It's usually not that hard. So I think this is a very powerful mechanism for implementing polymorphism. But Ruby also has really good polymorphism, right? We have duck typing. Duck typing is the idea that in Ruby you just implement the same like collection of methods, and as long as they have relatively the same semantics, you can just pass classes like objects in, as long as they have the same method. Like, look, everything there quacks like a duck. I don't actually know if chickens quack. I don't think so. So what's the difference here? It seems like this is kind of the same thing. Like, really what we're doing in Go is compile time duck typing with an explicit declaration of what our interface is. And I think that that's actually a really good way to look at it. It's like you are doing the same type of polymorphism, but you're doing it and you're checking it safely at compile time. Meeting in 40 minutes. In Ruby, both interface requirements, both the methods that you need to have in order to safely pass into a function, and the fulfillment of those requirements are implicit. You have to kind of look at the code and figure out what they are. On the other hand, in Go, the fulfillment of an interface is still implicit. You don't have to declare that your type fulfills an interface like you do in Java or C#. It's completely, like, you just organically grow out your class and it starts fulfilling interfaces. But the requirements of the interface are explicit. And I find that that makes it a lot easier to reason about what they are. How often have you guys written a class in Ruby, or a collection of classes that were using some sort of duck typing polymorphism, but the interface of those classes was more than like one or two methods? I find that I do that very rarely. I often need to I find it difficult to reason about what the requirements to actually have the thing work are because there's no place to put them in Ruby. There's no like list of you must do this in order to be this type. I mean, of course, this is part of Ruby's big, it's a dynamic language. Like it works pretty well when it works. But here, you can have the requirements be very explicit, and you know exactly what there are. There's no surprises. I'm not going to talk a lot about the lack of inheritance. I think that if you want to read about that, Sandy Metz has a lot of good articles about how inheritance is kind of unnecessary for object-oriented code. You can always solve a problem through some other way if you're solving it through inheritance, usually composition. But yeah, so Go agenda number 3, upfront error handling. I think this will actually be by far the most controversial point. Treat errors like ordinary data. Minimize the use of exceptions for control flow. And tactically, the way we'll almost always do this is just have multiple return values. So often in Ruby, in Go, when I call a function, I get back the result of the function and an error. And then I check if the error was nil. If it was nil, then I have to somehow handle it. And if it wasn't, I just keep going on with my life. So here's an example of real code in the standard library that does this. It's sort of like a fancy typecaster. It basically like takes a string, and if it knows like, that string is trying to be true or something, it casts it to a Boolean and then returns. And if it can't recognize it, it just returns an error. So I think this is like a very simple code. There's identical types of functions for like ints that are actually slightly more complicated because you have to say which size of int. But I think it's like pretty straightforward. And then to use it, here's a little program that will use it. In our print parse result function, we take some input and we just delegate to the parse bool function that I just defined, and we get result or an error. The error might be nil. So we check if the error is nil. If it's not, we have to somehow handle it, in this case by printing out a different string. And if it is nil, then we just proceed as normal. And the results here will be that print parse result will work, and that's, it'll just go, I think it's pretty self-explanatory. Interestingly, though, look at what's going on here. There's no special control flow mechanisms here. All I'm doing in order to handle the error is just using an if statement, the same as I would for any other type of like switch. There's no need to have a rescue. There's no need to throw exceptions. It's just code. It's just simple code with no like exception control flow. I find that this is nice because it forces you to always think about the errors as you're writing it. It's very easy in Ruby to not think about the exceptions that your functions might raise, right? Just write some Ruby code, like calls out to like active record or whatever, and just keeps on going. And like, yeah, you think to yourself, oh, I guess it might raise an exception, but like, I'll deal with that if it happens in production. Then I'll fix it. With Go, it's like bulletproof Go code looks very much like normal Go code, because you're always handling all the errors. I have a slide here about how similar types of operations might raise in Ruby, but I don't think I have time to do it. So compare with Ruby, it's like you don't need special control structures. You have no surprises. Moreover, similarly to how with Go, the interfaces are present and explicit, and that makes them easier to reason about. With Go, the errors are also explicit and there. It's very easy to say like, oh, if this happens, I can just like throw it up the call stack, but if this happens, I can handle it. Now, what are the disadvantages? Because I think there are big disadvantages to this approach. One is just that you're just going to end up spraying if error is not nil everywhere in your code. It's like, I think someone found that it was like 17% of lines of code in one particular package. And so then like the Go guys came back and were like, no, that package was written badly. Like, okay. But it ends up going everywhere. I'm serious. And it can kind of make your functions very noisy. Like if you want to do a series of like fairly simple operations, you end up with like 10 different potential exits from your function because of error handling. And often it's just a distraction. Like if I'm writing a web application and I get an error writing to the database, I should really just blow up. Like I don't need to handle anything else there. There's nothing I can do. So yeah, like handling errors locally is not always possible. But then you have a dilemma because it's like, if you just pass them up your call stack, you now have a very leaky abstraction, right? It's impossible to build fully abstracted code when you can get an error that's from like, 5 levels down in like your call stack, and there's no possible way that the higher level function will be able to deal with it. On the other hand, like, like, what are you going to do? Like, often I find when I'm writing Go code that I just pass things up, and that's actually really implementing the same type of thing as exceptions. I should say, by the way, that Go does have an exception-like mechanism called panic. It has slightly different operational meaning than an exception in Ruby, but the point here is that it's extremely unidiomatic to use them. I think we should think about this. We could actually do this in Ruby, right? Ruby has multiple return values. We could totally do this. I think that it's a big trade-off, though. So this is just something to think about. OK. Got about 7 minutes left. Let's just do some lessons learned. Go is a very small language. Go code almost always looks the same. Unlike in Ruby, where it's possible to transform what the language looks like with different libraries, different kind of things that you can throw in, like things that I would think about are like Rails transforms the way Ruby looks like a lot of the time. Celluloid, things like RSpec. They transform what the language looks like. Go code always looks the same. This makes it easy to pick up and easy to learn, although it does mean it's not as flexible. I will say that there's a big advantage here, though. To me, when I'm looking at code and I want to review it, there's a couple steps you have to go through, right? You have to look at it and you think, like, OK, like, what is it trying to do? And then you have to say, like, how is it trying to do that? And really what you want to get to the point is that you understand both what it's doing, how it's doing it, and you want to critique the design. You want to critique the decisions that were made in order to get to the point of doing a particular thing. If your code always looks very similar, it's a lot easier to get to that point. Things that are familiar are easier to like parse. You don't have to go into like human compiler mode to like figure out what it's supposed to be like actually doing. It's easier to like make design critiques when the code generally looks the same. I think that this is one of the big reasons why language idioms emerge in the first place, is that it gives us, like Ruby is a huge language, there's tons of possible ways to do things. If we can kind of concentrate on a small set of them, it kind of gives us a smaller dialogue, a smaller like range of possible things to reason about, which makes it easier. On the other hand, flexibility is a big thing to have, and you're definitely sacrificing it with a language like this. The other thing I would say is that Go is very explicit. In the same sense, it makes things very easy to reason about because they're there. I think that if I were to draw a line, I would say that Go's approach to interfaces is really, really good. It really makes it super easy to just figure out, like, what exactly do I need? What is the bare minimum requirements that I need from this class in order to treat it like something? On the other hand, the error handling style that I've described often makes things extremely verbose and extremely clunky. There's definitely a lines of code multiplier effect going on here. And I think a lot of people would tell you that, like, the fewer lines of code, the better, almost always. So, OK. Finally, just stepping back one other layer, learning more languages is awesome. I think it's very important to emphasize that we as programmers, as developers, as engineers, whatever you want to call us, we're always working with tools that make trade-offs. If you don't have any other idea of what your tool could look like, you are unaware of the trade-offs that it's making. I think it's very, very dangerous to just think of yourself as like a Ruby programmer or a Java programmer, because then you're basically saying that like you're married to that particular set of trade-offs. You need to pick the right tool for the job, not the tool that you have like just put up in your head as the best. I think it's like, even if you like look at this talk and you're like, OK, Go, like, I don't know, which I think is like a completely legitimate response. I think it's very important to be aware that like Ruby is making trade-offs. Ruby is being very, very flexible at the expense of being very complicated. Ruby is being very, very implicit at the expense of often kind of being hard to reason about. And if you guys who have like done a lot of metaprogramming will know what I'm talking about. So just like try out new stuff. That would be the big takeaway message I would give. If you want to learn more about Go, we've got about 5 minutes left. I would recommend that you go down this list of talks in order. I love watching Go talks on YouTube. It's excellent preparation for doing stuff like this. Go at Google explains why the Go language was invented. Basically, the answer is that at scale, C++ takes a really long time to compile. The rest of these talks talk about like Go's concurrency constructs, which are super interesting and super cool. Writing web apps using just the standard library is actually possible in Go. So the hallmark of a modern language is that it has like a very advanced standard library. Bear in mind when I say modern language, like Ruby is as old as PHP, so like, you know, it's not Matz's fault because he invented the thing in the 80s. And by the time you get down to advanced Go concurrency patterns, you're going to be like, your mind's going to be blown. There's also a talk that I didn't throw up here about how to write a highly concurrent parser in Go that Rob Pike gave, but I forgot what it was called. So anyways, have fun. And do you have any questions? All right, in the green.
So how does, I assume Braintree uses Go and Ruby, and I'm just wondering if you can talk about like where you use which and how you
Right. So the question is, I assume Braintree uses Go and Ruby, and can you talk about like where each one is used? So Braintree actually doesn't use Go in production anymore. Braintree is like, we have a history of being very experimental and very welcoming of like, you know, hipster languages and new technologies and whatever. We also have a history of using them in exactly the wrong spot. So it's like, we were like, oh, let's try out Go. And so we used it on this like very, very simple CRUD web application that's like one of some auxiliary service. And it turns out that if you're going to do this for any language that's relatively young, you're going to have a couple problems. Like, one, no one's ever written a library for gracefully restarting a web server. No one's ever like really solved logging. No one's ever really done crash mailing. Like all these things that you kind of have been completely battle tested in the Ruby community, we had to go out and reinvent. And we found after like a couple months that we had a particularly bad incident where the SQL driver we were using actually like could not handle concurrent load in Postgres without corrupting data. And we were just kind of like threw up our hands. We were like, look, we can't fix like writing web apps in Go on our own. It doesn't make sense for an application this small. So we ripped it out and rewrote it in Ruby. So that experience, I think, had nothing really to do with Go as a language and everything to do with like us kind of picking the wrong project and kind of the open source community is not as mature as it is in Ruby. Now, that was over a year ago, so if we were to do the same thing today, things might be different. And we actually were able to open source a lot of the work we did. So, yeah. There was another question?
Yeah, what would you say is a good use case for Go?
So I think that web applications where speed is a factor would be good. Oh, sorry, yeah. The question is, what is actually a good use case for Go then? I think, so one example is that Braintree is starting to service out our formerly monolithic payment gateway into several different services. I think that we might end up having to have like some sort of routing layer that acts as a front end to entry to our main like cluster. Go would be a good choice for the routing layer because it's all in memory and you would be able to like parallelize all the I/O pretty well, which would be awesome. I think if you're writing a web application where you actually do need to worry about like CPU time, it's a good choice. Another thing that's interesting that's really starting to emerge is like DevOps tools. So things like Puppet and Chef, you can often get a lot of benefit from the sort of error handling style and from really easy to reach concurrency constructs. Any other questions? Yeah, right there.
So a language like Haskell would let you hide some of the error handling that's done there by allowing you essentially to chunk up the success cases and have it short circuit to the end as the error case. Is there any sort of equivalent to like the error monad in Go? Or is it all just if else, if else, if else?
So the question is, in Haskell, you could use the error monad, which would essentially group all the error cases together into a single return, and as opposed to having like if-else return, and so forth. The answer is that it's not possible to write the error monad in Go because Go doesn't have generic functions. So no, I think that you can definitely get into a pattern of trying to do things with as few early returns as possible. And maybe if you're doing too much stuff, you might want to re-examine whether it makes sense to be a single function. But one thing that I don't like about Go is that it's not possible to write generic, like, there's no generic types. You can pass around like we'll quote the empty interface and then typecast to whatever you want. But at that point, it's like, why are you using a static language? Like,
You already mentioned the problem of the not stack unwinding when you throw errors or if you do error handling. So do you actually consider that good or bad if you can't do that in Go? That you have to handle everything with if and else?
yeah. So so the question is that with to paraphrase it, in languages with exceptions, you get a nice stack trace when you get an exception. With Go, you'll kind of get an error that says like, couldn't write to file, but you don't actually know like where that came from. I find that in practice, this actually is not as big of a problem as you might think. I think if you find it's a problem, you can always manipulate the error that you send back up at each level of the call stack, which you can add actually more context than you would with just a like line number, right? But I agree, it's definitely something to think about. There's a tension between handling errors very explicitly and handling them so that they don't make up the entire program. Are we out of time? Okay. One last question? There you go.
Would you consider Go a good candidate for like native extensions?
So the question is, would I consider Go a good candidate for native extensions?
Assuming the bridging layer exists.
Yeah, so there is like a lot of C-Go interfaces, and I think that people, when they have had this problem, have tended to just use the C-Go, like maybe as like a higher level thing to manipulate C code. Yeah. Okay, thank you guys.